The Master Electrician exam differs significantly from the journeyman exam. Firstly, there were no conduit fill questions. Secondly, box fill questions were limited. Thirdly, there was an emphasis on neutral sizing. Calculations were present but of moderate difficulty. Some questions were classified as off the wall, necessitating efficient codebook lookup. Some questions were simple, covering basic electrical knowledge. The hardest questions were concentrated in the first half of the test. To prepare, one must study all topics thoroughly. Know how to use the codebook index efficiently. Be prepared for unpredictable questions that might not be encountered in practical applications. When sizing neutral conductors, followed the guidelines in Article 220.61 of the National Electrical Code. This section provides the requirements for calculating the neutral load for various types of services and feeders. For example, in a dwelling unit, the neutral conductor must be sized to carry the maximum unbalanced load. This includes 100% of the first 2000 amps of the unbalanced load plus 70% of the unbalanced load exceeding 2000 amps. For electric ranges and dryers, the neutral demand factor is typically 70%. In commercial buildings, the neutral load calculation depends on the type of loads served. For feeders supplying electric ranges, ovens, clothes dryers, and water heaters, the maximum unbalanced load can be reduced based on the demand factors in Table 220.55. For nonlinear loads, such as those from electronic equipment, the neutral conductor may need to be sized to carry the full calculated load due to harmonic currents. Neutral conductors carrying harmonic current should be sized no smaller than the phase conductors. When performing electrical calculations, ensure you understand Ohm's law, which states that voltage equals current times resistance, of volts equals amps times ohms. Power calculations are also crucial. Power in a direct current circuit is calculated as voltage times current, or power equals volts times amps. In an alternating current circuit, you must consider the power factor. The formula for single-phase power is power equals volts times amps times the power factor. For three-phase power, the formula is power equals volts times amps times the power factor times the square root of 3, which is approximately 1.732. When using the codebook, the index is your most valuable tool. Practice locating information quickly. For instance, if you need to find the allowable ampacity of a conductor, start by looking up conductor ampacity in the index. This will direct you to the relevant tables in Article 310. For box fill calculations, refer to Article 314.16. This section specifies the volume required for each conductor, device, and fitting in a box. Remember to account for all conductors, including grounds and equipment grounding conductors. The number of conductors permitted in a box is based on the volume of the box and the size of the conductors. For example, a number 14 American wire gauge conductor requires 2.0 cubic inches of free space, while a number 12 American wire gauge conductor requires 2.25 cubic inches. For equipment grounding conductors, you must count the total number of equipment grounding conductors entering the box as one conductor based on the largest equipment grounding conductor. For devices such as switches and receptacles, each device counts as 2 conductors. Be prepared for questions that seem unusual or outside the scope of typical field work. These questions often require you to interpret specific sections of the codebook. For instance, you might encounter a question about the grounding requirements for a specific type of equipment or the overcurrent protection requirements for a particular type of circuit. Always refer to the relevant sections of the codebook to find the correct answer. Remember to review the basic electrical principles such as series and parallel circuits. In a series circuit, the current is the same through all components, and the voltage is divided among the components. In a parallel circuit, the voltage is the same across all components, and the current is divided among the components. Also, understand the concepts of impedance, reactance, and power factor. Impedance is the total opposition to current flow in an alternating current circuit and includes both resistance and reactance. Reactance is the opposition to current flow due to inductance and capacitance. Power factor is the ratio of real power to apparent power and indicates how effectively electrical power is being used. When answering questions, pay close attention to the wording. Often, the question will contain clues that can help you eliminate incorrect answers. If you are unsure of the answer, try to eliminate the options that you know are incorrect and then make an educated guess from the remaining options. Manage your time effectively during the exam. If you encounter a difficult question, don't spend too much time on it. Mark it and come back to it later if you have time. Focus on answering the questions that you know well first, and then return to the more challenging questions. Remember that the codebook is your primary resource during the exam. Become familiar with its organization and how to quickly locate the information you need. Practice using the index and the tables to find answers to various types of questions. Understanding the difference between grounded and ungrounded conductors is crucial. Grounded conductors, typically neutral conductors, are intentionally connected to ground to provide a return path for fault current. Ungrounded conductors, typically hot conductors, carry the electrical current from the source to the load. Grounding is essential for electrical safety as it helps to prevent electrical shock and equipment damage. Equipment grounding conductors provide a path for fault current to return to the source, trapping the overcurrent protection device into energizing the circuit. Bonding ensures that all metallic parts of an electrical system are connected together to create a lower impedance path for fault current. This helps to minimize the risk of electrical shock and fire. Review the requirements for overcurrent protection, including circuit breakers and fuses. Overcurrent protection devices are designed to protect conductors and equipment from excessive current, which can cause overheating and damage. The size of the overcurrent protection device must be matched to the ampacity of the conductor it is protecting. Also, understand the different types of overcurrent protection devices and their applications. Circuit breakers are reusable devices that trip when an overcurrent occurs, while fuses are one-time use devices that must be replaced after they blow. Remember to study the requirements for wiring methods, including conduit, cable, and wire. Conduit provides mechanical protection for conductors and is available in various types, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Cable consists of two or more conductors enclosed in a protective sheath and is available in various types, such as non-metallic sheathed cable and armored cable. Wire is a single conductor that may be insulated or bare. The type of wiring method used depends on the application and the environmental conditions. When selecting conductors, consider the ampacity, voltage rating, and insulation type. The ampacity of a conductor is the maximum current it can carry safely without exceeding its temperature rating. The voltage rating of a conductor must be equal to or greater than the voltage of the circuit in which it is used. The insulation type of a conductor must be suitable for the environmental conditions in which it is installed. For example, conductors used in wet locations must have moisture-resistant insulation. Be familiar with the requirements for electrical equipment, such as transformers, motors, and generators. Transformers are used to step up or step down voltage. Motors are used to convert electrical energy into mechanical energy. Generators are used to convert mechanical energy into electrical energy. Each type of equipment has specific requirements for installation, wiring, and overcurrent protection. Understanding the requirements for different types of occupancies, such as residential, commercial, and industrial, is essential. Each type of occupancy has specific electrical requirements based on its intended use and the number of occupants. For example, residential occupancies have requirements for ground fault circuit interrupter protection in bathrooms and kitchens, while commercial occupancies have requirements for emergency lighting and fire alarm systems. Review the requirements for special systems such as fire alarm systems, emergency lighting systems, and communication systems. Fire alarm systems are designed to detect and alert occupants to a fire. Emergency lighting systems provide illumination in the event of a power outage. Communication systems include telephone, data, and audio systems. Each type of special system has specific requirements for installation, wiring, and testing. Also, Study the requirements for hazardous locations, such as those containing flammable gases or dusts. Hazardous locations are classified based on the type of hazard and the likelihood of its presence. Electrical equipment used in hazardous locations must be designed and installed to prevent ignition of the hazardous substance. Review the requirements for renewable energy systems, such as solar photovoltaic systems and wind turbine systems. Solar photovoltaic systems convert sunlight into electricity. Wind turbine systems convert wind energy into electricity. Each type of renewable energy system has specific requirements for installation, wiring, and grounding. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are required in bathrooms, kitchens, and other locations where there is a risk of water exposure. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arcing faults. SIs monitor the current flowing in a circuit and quickly interrupt the power if an arcing fault is detected. SIs are required in bedrooms and other locations where there is a risk of fire. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other disturbances. SPD divert the surge current to ground, preventing damage to the equipment. SPD are recommended for sensitive electronic equipment, such as computers and televisions. Review the requirements for energy efficiency, including lighting controls and energy management systems. Lighting controls can be used to reduce energy consumption by automatically turning off lights when they are not needed. Energy management systems can be used to monitor and control energy usage in a building. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and safety glasses. To energize circuits before working on them, and use lockout-tagout procedures to prevent accidental re-energization. Test circuits to verify that they are energized before working on them. Be aware of the potential hazards of electricity and take steps to minimize the risk of injury. Familiarize yourself with the latest edition of the National Electrical Code, as it is updated every 3 years. The NEC contains the latest requirements for electrical installations and is essential for ensuring electrical safety. Consider taking practice exams to assess your knowledge and identify areas where you need to improve. Practice exams can help you become familiar with the format and content of the actual exam. Review the results of your practice exams and focus on studying the topics that you missed. Seek guidance from experienced electricians or instructors. They can provide valuable insights and answer your questions. Attend workshops or seminars on electrical code and exam preparation. These events can provide you with the latest information and help you prepare for the exam. Remember to stay calm and focused during the exam. Read each question carefully and take your time to answer it accurately. Use the codebook to your advantage and don't be afraid to look up information if you are unsure of the answer. Trust in your knowledge and preparation, and you will be successful on the Master Electrician exam.